Hi, hello, this is Yoga Priya, Assistant Professor, Department of Physics. So, today we are discuss about Kirchhoff's law. Kirchhoff's law is a two fundamental rules of electrical circuits theory which analyze the electrical circuits. So, first one, Kirchhoff's law, fundamental circuit analysis. So, discovered Kirchhoff's law, that bedrock of electrical circuits theory, developed in 1845. These laws are crucial for anything or complex electrical networks. And then Kirchhoff circuit laws lies at the heart of circuit analysis, with the help of these two laws and equations for individual components, resistor, capacitor and inductors. So we have the basic tool to start analyze the circuit in the article. We will discuss Kirchhoff's currents and voltage law and how to them in circuit analysis. The first one, Kirchhoff's current law, KCL. So Kirchhoff's current law, according to the KCL, the total current entering a junction, a node, is equal to the charges leaving the node as no charge is lost. The statement of the total current entering any junction or node in an electrical circuit is equal to the total current leaving at the node, charge is conserved. Put differently, the algebraic sum of every current entering and leaving the node has to be null. Is properly of Kirchhoff's law is commonly called conservation of charge equal to 0. So in this principles, KCL is the principle of conservation of electrical charges. No charges accumulated or dissipated at any junction, it simply distributed. And this applications of Kirchhoff overview applications, KCL and calculations and practical uses. So circuit consider a simple node where the current 5A and 12 MA is flow in the flow out. When applying KCL, according to the KCL is sum of incoming current equal to the sum of outgoing current. So sum of the current equal to sum of the outgoing current. So and the next, Kirchhoff's voltage law, KV. So according to the Kirchhoff's voltage law, the voltage around a loop, the sum of every voltage drop in the same loop for any closed network and equals 0. Put differently, the algebra sum of every voltages in the loop has to be equal to 0, and this properly of Kirchhoff's law is called conservation of energy. And then this principle of Kirchhoff's voltage law is a directly consequence of the conservation of energy as charge move around a closed path. So it's used only a closed path. Kirchhoff's voltage law is only applicable for closed loop or closed circuits. So we have to include the current and resistance if neither gains or loss or net energy. Yes, Kirchhoff's volt law applications and examples. So Kirchhoff's voltage law is widely used in electronical engineering to analyze design circuits, and then circuit setup and applications of KVL and calculations and practical uses. So analyze of complex circuits. So KVL help to determine the unknown voltages, currents and resistance in the circuit with multiple loops. And then example, solving analysis problems in DC and AC circuits, and then verifications of Ohm's law in loops by applying KVL can verify the sum of potential difference matches of the applied voltage confiring in circuit corrections, and the applying and KVL the sum of the voltage around the loop 0. And the practical uses is KVL is used to critical to analyze the series circuits, allowing calculating of unknown voltages drops across the components. And the next applications of Kirchhoff's law. So there are critical design and troubleshooting, network analysis, and power systems and electronics. So we have lots of fields is used in Kirchhoff's laws. The first one, electrical circuit analysis, used to find the unknown currents and voltages and resistance, both simple complex networks, and form the basics of KVL and nodal analysis of KCL. And then power distribution systems, so ensure the voltage drops in a transmission lines with supplied voltages of KVL. Then balance current flow at distribution points of KCL. So circuit design. So engineers used Kirchhoff's laws to calculate the components value of optical circuit performance, ensuring the functionalities. So electronics we have to use for amplifiers and digital circuits for the understanding diverse electronic devices. And the power systems we have to use to the analysis of power flows and voltage drops and system stability and ensuring the reliable distributions. And the network analysis we have to use to the solving complex multiple and multi-node electrical circuits. So, and the final of conclusion, the power of Kirchhoff's law. So, Kirchhoff's laws, KCL and KVLs are fundamental tools in electrical engineering that apply the principles conservations of charge and energy of electrical circuits. So, we have to use the universal principle describing fundamental circuit behaviors, and then advanced concepts in electrical engineering and analysis, and then both the analysis and designs of electrical systems and understanding and innovating in the world of electronics. Thank you so much for watching.